Hello, Year 11. This session is on physics, specifically the waves required practical, which appears in paper 2. Have a go now in silent solo for 10 minutes on question 1 and press play again after 10 minutes. Off you go. I hope you've had time, your 10 minutes to have a go at the question. Let's have a quick look at it. So when you read through the question, you can see this practical requires you to work out the speed of a water wave. So you'll notice this is not like many of the practicals we've looked at. We're not changing changing something to look at the outcome of that. So this is not a SID-SAM or a variable practical. We're simply trying to measure the speed of a water wave. So that's the first thing to note. The second one is this is a physics required practical. So there's usually an equation that can go alongside this. So that's what I'm going to have a look at first. It talks about the speed of a water wave. So I'm just going to go refer back now to your formula sheet. So if you have a look at this equations formula sheet, there's two sides to it. This is the first side. This first side only had equations on that predominantly come up in paper 1. And on the back of the piece of paper, at the top you've got paper 1 material, and then you work down paper 2. As this is a paper 2 topic, we can find the equation right down here. We want to work out the speed of a wave. We need to work out the frequency and multiply it by the wavelength. So we can go straight away now to our question. And I'm going to make a quick note of that because I'm not sure what the question's asking me yet, but that is something that's quite important. Then the figure 1 below, so that's the diagram that's shown in this particular question, talks about the equipment. It's got a ripple tank that's got some water in it. There's a bar that goes up and down and forms waves on the surface or ripples on the surface of the water. And there's a light source, so you can see shadows on the screen below. So that'll show you when the waves go up and down on the screen below the table. So your question is to describe, so not why, just what are you going to do? So effectively a method, do this, do that, do the other. How are you going to use the equipment in figure 1? So we need to refer to this equipment here to measure the wavelength, frequency and speed of water wave. So we've already identified a couple of things. Right at the start, we said the speed was the frequency times the wavelength. So if we want to work out the speed, then we're going to need to work out frequency and work out wavelength. If we know both of those, we can multiply them to get to the speed of the water wave. So as this is a 6-mark question, obviously we need to cover quite a bit of science in this one. It's asking how to use equipment, so it's effectively a method. So you don't have to, but certainly numbered bullet points would be sensible. Imperative verbs, so bossy verbs would be useful. And let's have a look. We're going to break this down, I think, into three major sections, 2 bigger sections, a smaller one. So I think we need to talk in quite detail about how we're going to measure wavelength. We need quite a bit of information about how to measure frequency. Then the third one should be quite short because it's simply a matter of saying multiply the 2 together. Let's have a look at wavelength. Just going to move that slightly further over to the left. But to make it nice and clear to the examiner, I'm going to work out wavelength. Now, wavelength is simply the distance between the peaks of 2 waves or troughs of 2 waves. So how can we go and do that? Well, we can see on the diagram, we have a screen, and that screen actually has all the waves shown as shadows on the bottom of that screen. So if we can work out the distance and we can see how many waves there are, we should be able to work out the distance of a single wave. But the current is missing a piece of apparatus. So it says distance there, but it hasn't actually said with what. So I'm suggesting we place a ruler next to that screen so we can actually measure distance. Now, the next thing that's quite difficult is the waves are quite small. So if you measure a single wave, you're not going very accurate. It's probably better to measure a longer distance, maybe 10 waves, and then divide that number by 10. You should have a more accurate measurement of a single wave. And the last thing that's quite difficult is that little wooden bar is going up and down. causing ripples constantly, which means that screen is showing an ever-moving picture. So it's going to be quite difficult to measure the distance if they're not static. So my suggestion would be maybe to take a photograph, either on your iPads, camera. Some of you might have had fancy equipment in your school. You might be able to actually freeze that particular image. But either way, we certainly need to capture that image so we can actually measure that distance. I'm going to go for the easier one of just taking a photo. So let's just talk through what we've done. So imperative verb. So number 1, place a ruler along the screen. Okay, so have you said anything about measuring the distance? Number 2, take a photograph. Of the screen. So now we have a photograph with distance on it. Now we can measure the distance of 10 waves. It doesn't have to be 10. I just find things are easier to divide by 10. So I've just picked 10 for that reason. So now if I know the distance of 10 waves, I've simply got to take that distance and divide by 10. And I now know the distance of 1 wave. Hence we have our wavelength. So now we have clearly stated how we're going to measure a wavelength. I've done that one. Let's have a go now at frequency. So frequency is how many items pass a certain point in a certain time. So in this case, it would be waves. So how many waves go past a certain point in a certain length of time. So effectively, we're going to need another piece of apparatus not shown here. If we're going to time anything, we need some form of stopwatch. We're then going to have to watch these waves. So this time we're not going to freeze it. We're just going to simply pick a point. We're going to start the stopwatch and we're going to time until a certain number of waves have passed that point and then measure that time. And again, just like we did with the wavelength, we can then divide one by the other to identify the frequency. Okay, so first of all, we're going to use a stopwatch. Time how long it takes for 10 waves to pass a certain point. Doesn't matter where, as long as you keep to a point. Now, as I said, frequency is how many some things happen in a certain time. So we're now going to divide the number of waves by the time it took. So now I've got frequency. I now know how many points pass a key point in a second. Right, so now I've got those 2 points, 0.3. I need to get to the wave, actually measure the speed of the wave. Now, those amongst you might have realised I've missed a point. I've decided to include it here. I have measured once the distance of 10 waves, and I've measured once the time it took for 10 waves to move. What if I happen to get distracted? What happened if I mismeasured? So we need to really repeat all those points, numbers 1 all the way through to 6, at least twice more, so we can identify any anomalies and then work out an average mean. And the average mean will be calculated just as it would in a maths lesson. Add the numbers up, divide by how many numbers you have. So to get that speed now, we now simply need to multiply the average wavelength by the average frequency. Okay, I certainly won't be expecting everyone to get every one of those points necessarily, but look at the format of the question. I've identified 3 individual items. I've used a physics equation sheet to identify the key equation that's going to help me do that. I've done my best I can to explain how I'm going to measure wavelength and how I'm going to measure frequency. And I've tried to explain how to use those 2 points. The more of those points you can make, the more marks you're going to get. Because the key point here is, are you going to get a valid response? So are you actually taking measurements that are going to actually give you the data that's going to help you work out what's been asked? And the closer you get to that, the more marks you're going to get. So that was the bulk of what this session was about. There are 2 other questions, and I'll quickly go through those with you now. So we have this little duck here. The duck is bobbing up and down. However, the water's moving and the water transfers energy. And that transfers, I'm going to assume, is either to the right or the left. So I'm going to suggest it's this way. Now, what might be interesting is, as the wave's moving in that direction, the duck will continue only to go up and down. It won't move along with the wave. If you're not sure about that, feel free to practice. I guarantee you it's not going to go anywhere other than up and down. So it's asked you to identify how the movement of the plastic duck in that figure demonstrates the water waves are transverse. That simply means that the water direction of travel of the water is in this direction, where the movement of the particles in that direction. That's a right angle, so that's perpendicular. Now, you cannot just put the word perpendicular because of the way the question's phrased. So you need to actually state that as the duck is moving perpendicular to the direction of the wave travel. Okay, you can't just put the word, nor can you just put right angle. You have to use that key word. I'm sure some of you about now are thinking, can I spell perpendicular? Your spelling is very important and you should prioritise it. Luckily for you, in a science exam, if the examiner can read what the word is meant to be, you will still be okay. However, I cannot emphasise the importance of correct and accurate spelling. We'll move on to the last one. This one was a little nasty, but it's a really good one for just teaching you a couple of key points. It's actually here to calculate a mean. It's just what it says in maths. A mean average in science is the same as a mean average in maths. So most of you are probably fairly good at that, but we'll have a go at it anyway. But it's asked for the mean amplitude, and amplitude is not in the question. You do, however, have a maximum height and a minimum height the duck went. So if I remind you an amplitude, if this is a wave, it's the distance from the midpoint to either the peak or the trough. That's the amplitude. What you've been given, however, is this distance from there to there. So you've been given the height and the minimum height. So we can actually use those two to measure the total distance. And if we halve that, we can work out the amplitude. The year that this was sat, very, very few students actually got to that 3rd mark. It was very unusual. So if you did get that, massive well done, it was unusual. So we're going to do the maximum mean height first. So in maths, just like you would do in any maths lesson, add up the 3 numbers for the maximum and divide by 3. Just remember to press equals before you press the divide by 3. You can always ask your maths teacher about BIDMAS and why it won't work if you don't. But make sure you add them all, press equals, then divide by 3, or use brackets. Then we're going to do the same for the minimum height. Going to add the three minimums together. Remembering to press equals now before I divide by 3. So that's giving me this height, the maximum height of 511 and the minimum height at 500. So I'm looking at the difference between the two. So I'll simply take the two away from each other. So that's the total height. So that's this bit in red here. I only want the amplitude, which is half that. So I just need to remember to divide it by 2. If you got that, massive well done, because that was quite a hard one to do. You have another question that's very similar to practice that with. Your teacher has all the answers, so you can double check with them when you need to. Good luck. Bye.